I'm continuing discussing Chapter 1 of The Beginning of Infinity. David talks about the purpose of science. He says it's not prediction. He gives an example. Suppose you're watching a magic show and the magician saws someone in half. You could probably predict that they're going to be fine. However, that doesn't mean that you know how the trick works. Being able to predict the outcome, that the person will be whole and never have been sawed in half, does not mean that you understand how it works or what's going on. So there's a big difference between predicting something and actually understanding it. And science seeks understanding and explanations. There are lots of ways people think and talk about explanations, and they don't always recognize that explanations are involved. One place we use explanations is whenever we categorize things, which I'll talk about more later. Another one is having a mental model of something. That means you're trying to understand it and explain in some way what's going on. Similarly, if you understand the mechanism or the process, or usually the law, there's usually an explanation involved. If you've read The Fabric of Reality, I really like the oracle example from that book that helps illustrate why prediction is not good enough. In the book, there's a thought experiment where you have an oracle and you can ask it questions and it will always give you correct answers. So you can have it predict anything you want. Like you can design something, a rocket ship or a computer or something, and then use the oracle to find out things about whether it will work. And this would have some value and some use, but it's a lot more limited than people might think as their first impression. It sounds like, oh, it'll just tell us everything. This solves all our problems, but it wouldn't be like that. If it tells you your rocket ship design is going to crash and burn, that does not tell you what to do to fix the problem. You have to understand what sort of rocket ships might work. If you don't even know what things like flammability are, if you don't have concepts, then just endlessly putting in different rocket ship designs and seeing if they'll reach outer space or not is a bad way to design spaceships. And actually, we already have an oracle. The oracle is reality. You can find out the results of a particular rocket ship design or a particular science experiment or whatever just by doing it in reality, and then you get your answer. But that doesn't necessarily help you understand why you got that answer and what's going on. So one of the key points here is that appearances are not self-explanatory. David uses an ongoing example of a conjurer who I would more commonly call a magician. It might be an American versus British thing. So the kind of people who do magic shows. And they also sometimes do tricks on the street. They can be street performers. It doesn't have to be a show. So people often try to trick you. Nature does not intentionally try to trick you, but it doesn't really make that much difference because appearances are not self-explanatory. You can easily be tricked by nature. You need some of the same critical thinking to deal with magicians or nature. Nature is actually harder for people in a lot of ways because they're not on the lookout for a trick. Similarly, people do better at magic shows than at poker games where someone is using similar skills to cheat with cards. A lot of magicians do card tricks and they do all kinds of quick sleight of hand and stuff, and it tricks the audience, but the audience knows, oh, well, this guy's a magician, he's trying to do something. Whereas if you're at a poker game and someone does that to you, they might take your money and you might not realize anything had happened. So the warning that someone's trying to trick you is useful, and nature does not give you that warning. Anyway, the idea that appearances are not self-explanatory is similar to the idea that you can't just look at the data, see the pattern, and know what's going on. And as I explained previously, one of the reasons for that is that there are many, many patterns. And when it comes to appearances, there are many, many possible explanations. In fact, infinitely many, of why or how those appearances came to be, what's going on there. So David keeps talking about the conjurer and a cup and balls trick and stuff, which we're not going to go into in a lot of detail. And he starts criticizing instrumentalism. Instrumentalism says science offers only predictions, not an understanding of reality. So it's one of the main ideas David wants to oppose and argue with. And he holds a view called realism that says the physical world exists and we can learn about it, meaning that we can actually understand it. It's accessible to rational inquiry. We're not just limited to seeing a bit of data and making a few predictions. We can do better than that. So one of the ways instrumentalism is tricky is there are often hidden assumptions. People often understand things and have explanations, but they don't think about that. It's background knowledge, and that makes the instrumentalist ideas more plausible. It seems like they didn't have to do conceptual or explanatory thinking, and they made progress. Therefore, conceptual explanatory thinking must be unnecessary. And the critical rationalist answer to that is people often are using hidden assumptions, background knowledge. They know something about the context. They understand more than just the raw data and stuff. So you need to look around for what all this knowledge you have is and how you're using it to fully understand what's going on. So an example of using explanations is you might know that saws in magic shows are generally predictably safe. People don't get cut in half. But other saws, like in factories, are dangerous and really would cut you in half if you got into the wrong location. So to understand that, you need to know stuff about our culture and about what magic shows are. You have a lot of background knowledge that's helping guide your predictions that this saw over here is not going to hurt someone and that saw over there is very dangerous. So try to imagine explaining what magic tricks are to an alien and how to recognize a magic trick. If it's hard to explain it to an alien, that means there's a bunch of cultural knowledge involved. It means that growing up in our society and watching TV shows and having familiarity with these things is helping you understand what's going on. And so there's something involved other than data and prediction. So David defines a term, rule of thumb, which are claims that use background knowledge for their explanations. So background knowledge is knowledge that's familiar and uncontroversial. So you don't really have to think about it in order to use it and know it and apply it. And a rule of thumb is getting its explanations from background knowledge, so you might not realize that you have explanatory knowledge there because you take it for granted. Oh, he even says that. Usually take background knowledge for granted. So it can seem explanationless because you take the explanations for granted, but they're actually still there and important. So I came up with a couple examples. A rule of thumb could be bring 5 extra nails. But there's an explanation there that you might not say or even think about, but nails get bent or lost. That explains why it's useful to have extra nails. There are also other bits of context and explanation going on here. For example, this particular advice is something you can imagine being passed around between individuals who go work on construction projects by themselves or on fairly small projects. So 5 nails might be enough extras for a small project, but for a large project with hundreds of construction workers, you need a lot more extra nails, and you wouldn't want to deal with that by just having individual workers bring extra things. It's a different context. Another rule of thumb is you need 5 feet of leeway to park. If the cars, so you take the width of your car and you add 5 feet, and then you see if the space between the 2 cars is large enough. This is not a perfect indication. It is theoretically possible to park in a smaller space. But there are reasons that this rule of thumb works pretty well. You cannot drive in a perfectly straight line. You're always going to be swerving just a little bit here and there. You cannot be completely reliable about exactly where you put your car. You cannot judge the edges of your car. When you're sitting in the driver's seat, you have a pretty good idea of where the far left and the far right of your car are. and how they compare to the parked cars. But it's not perfect. You're going to be off by a little bit. Like, can you get it right reliably within an inch? Probably not. Within a foot? Maybe, but not 100% of the time, probably. And then you got to be pretty careful if you only have a foot of leeway. And also, when the other people, they might leave before you. So if you park really close and you're a perfect driver and so on, they might hit you on their way out. They might scrape you because they are not perfect drivers. And also, you need to have enough space to open your door to get out. It's possible that 5 is the wrong number. Like, I haven't actually measured. This is not a rule of thumb I actually use with the number. You know, in real life, I would just look at it and have an intuitive understanding of whether it's wide enough. But for an example, I just wrote 5 feet. 5 feet seems low, though, because if you only had 5 feet, that would be 2.5 feet per side, which is, I think that's too small to comfortably open your doors. So the point is, these rules of thumb have explanations. You can take a rule of thumb and then think about what explanations are involved. Why does it work? There's always some sort of reason that you could come up with for why it works. So David goes on to talk about the cup and balls trick, and if you don't understand how it works, then you wouldn't know what objects the balls could be replaced with. Maybe you could replace them with ice cubes or lighted candles or magnets. You know, some things are actually not going to work very well as replacements and some will work better. What if you replace the balls with rabbits that can walk around? You know, that could cause some trouble and make your trick not work. If you understand how the trick works and what's going on. But if you have no understanding, if all you have is predictions, then you wouldn't be able to make reasonable judgment calls like that. And David points out that it's only explanations that let us know what concepts to abstract out of the trick, what patterns to look for, what mental categorizations to use. So cup and balls are both mental categorizations, and they are not the only ones that we could use when thinking about the trick. We could call it the red and blue trick if it happened to be done with red and blue things. We could look at it a lot of other ways. It could be the plastic trick because all the things are being done with plastic, or the plastic and hands trick, or the plastic and outdoors trick if we saw it done outdoors. You might not necessarily understand that it could be done indoors or outdoors unless you have some explanation of what's going on, which helps you know what's relevant. That's one of the key points, is to judge relevance. What is relevant to what? You need some understanding of the stuff. That's one of the reasons you can't get by with just raw data. It doesn't tell you which data is relevant to which other data. So whenever we're using mental categories, we're using explanations. The explanations help us decide which categories matter. There are always infinitely many different ways that we could categorize things, and we have to decide what's relevant and important and useful, which categorizations to put attention on. Like calling something a cup or a ball is a typical category that we often find useful. Red and blue are also frequently useful, but not always useful. Similarly, if we were a scrap metal collector and there were metal cups and metal balls, we might not care about cups and balls. We might just see, oh, that is scrap metal, and that other thing over there, that's wood, that's not metal, we don't want it. So which categorizations are useful depends on what you're doing, what your goals are. It depends on context and situation. And being able to adjust for different situations and different contexts is part of what you gain when you understand things instead of trying to be an instrumentalist. So part of the difficulty I think people have is they don't always recognize when they're using explanations. So whenever you're making reasonable mental categories, you're using explanations. Otherwise, you wouldn't be able to judge what's reasonable or unreasonable, or useful or not useful. And so this is a thing you can practice. You can take examples from your life of mental categories you've used and try to come up with explanations for why they're reasonable, why they're useful, etc. So you can see how the explanation is guiding you, and you can do that with all sorts of things. Another mental category that we use is food and drink. We separate those. That's a common separation that is useful in many situations. And you could think about, why is that? Why do we separate those things in that particular way? We also have food groups like starches and proteins and dairy. And you could think about, why do we categorize that way? Is that useful? You could come up with dozens of other categorizations, and you could see how many of them would be less useful and more inconvenient, and maybe a few other ones would be pretty good as well. And if you had that experience, it might help you understand what the book is saying. So people do not have good intuition about there being infinitely many different ways to categorize things. And that's because most of them are unfamiliar to us. We don't use them. We don't find them useful. We don't talk about them. What we're used to is when we talk about categories, people only think about a few different ways of categorizing, all of which are pretty normal, familiar, standard, and tend to be pretty useful. But you could categorize things by object with over 500 protons in it or under 500 protons. Probably not useful in general. You could imagine very, very specific circumstances where that actually would be useful. You could come up with a hypothetical scenario where that's useful, but in the vast majority of circumstances that we deal with in our lives, that's not useful. And you could change it from 500 to 501 or 502, so you can get actually infinitely many just with this one thing. The really, really big numbers would be especially not useful. Like, if the numbers were big enough, then every single object in the entire galaxy would be in the under category and none would be in the over category. So similarly with red and blue. Red and blue are ways of categorizing color. When you say red, you're grouping together multiple colors into a single category. And how many categories should we divide colors into is a thing that we have understanding of and familiarity with and so on. And it could be done many different ways. So we could have photons with nanometer of wavelength between 692.4 to 692.7. And you could actually add decimal digits in order to get infinitely many different potential categories, because it could be 692.41, 692.411, 692.4111, and so on. You get infinitely many that way. Anyways, this is red, but it is only a very tiny range of shades of red. So it's not a very good category because it's too narrow. We don't need to be that specific when we're dealing with red. Sometimes red and blue is not specific enough. We might need dark red versus light red. So how many different reds we should distinguish and divide things into is actually a judgment call. And if we have thousands of different reds, that is usually not useful and actually just a hassle. But there are some people, artists and painters and stuff, who will sometimes actually worry about possibly 20 or more different shades of red. So understanding what your goals are and what categories will be useful to your goals helps you make good judgment calls for these things. So most unfamiliar categories are not that useful, not that good. We either have a category that's equally good or often much better. Most possible categories we would find really inconvenient and unintuitive and so on. However, there are some categories that would be really useful a lot of the time and we just haven't figured them out yet. There's some good ways of categorizing things in our minds that we just haven't thought of, but would actually be useful a lot of the time. But then most of the ones we don't use are not very useful. All right, so David goes on to talk about experimental testing. He says we can do tests when there are conflicting predictions. So you can do an experiment about the specific thing that they make a prediction about, and then at least one of them is going to be wrong. It's not going to match the data you get. More broadly, there's the idea of conflicting ideas. And this is what rationality, what productive thinking and progress actually deal with. Conflicting predictions is just a special case of conflicting ideas. It's one way that ideas can conflict is by making conflicting predictions. And so how do we deal with conflicting ideas? We use criticism and some other things as well. And then testing is a specific case of criticism. It's a way that we can try to find something wrong with an idea and refute it and rule it out. So a problem is a conflict of ideas. And so rational thought relates to problems and how do we solve them? How do we resolve these conflicts of ideas? How do we create ideas that don't conflict? By creating a new idea that doesn't have some of the problems in the prior ideas and supersedes them, or modifying the prior ideas to fix some of the conflicts. I've written a lot about this topic. This blog post is called Rationally Resolving Conflicts of Ideas, and then actually it just gathers together like 20 or so other things that I've written on this topic, plus there are a lot of comments discussing related stuff. So I'll put the link to this in the description. So David goes on to talk about how we have expectations. So the same trick could impress an adult who had a particular expectation, but not a child. Because the trick defies your expectation. It looks like something should happen and then it doesn't. That's impressive if you expected the thing to happen and somehow it didn't. But if you didn't have that expectation, if you'd never learned it and didn't understand in the first place, the trick might not interest you. Our expectations about what will happen relate to our explanations. We have an understanding of how the world works. We have a mental model of it and so on. And then when things contradict that, it attracts our notice. So David gives an example with stars. In general, we know unsupported things fall, and we know lights need fuel, and we know fuel is used up over time. And so you look at the stars, and you see that they shine constantly, and they don't seem to fall. And so that's kind of odd. That seems to defy our expectation. Not saying there's necessarily something wrong with our view, but there's something to explain there. Like, what are stars? How do they work? Is our general view about unsupported things or fuel wrong, or are stars some different thing? Maybe they shine in a different way. Like, what's going on there? You can wonder about it. You can wonder what holds stars up. Do they refuel, etc.? This is part of how we learn about the world and understand things, is looking for these disappointed expectations or clashes between ideas. Like, it appears to be this way, but I expected it to be this other way. That is a clash of ideas. That's a problem. And so, with effort, people figured some things out about the stars. That they're in free fall, that they do use fuel, that they do not run out, that they don't refuel though, and actually they can't last forever because of that. They will run out of fuel eventually, but it can take a very, very long time. Like, it can take literally 1 billion years for a star to run out of fuel. So, what do we talk about today? Science is about explanation, not prediction. Appearances are not self-explanatory. Realism is a better approach than instrumentalism. Rules of thumb use background knowledge, and there are actually explanations involved which you can think about and put into words if you put some thought into it. We talked about mental categorizations to help you see where you're using explanations and how common explanations are in everything we do and think. And at the end, there was stuff about conflicting predictions, which are testable, and ideas are criticizable. And our expectations are one type of idea we have, which can conflict with other ideas and be an area to think about and problem solve. So if you want to learn more, subscribe, and I'll see you in part 9.